Have you ever wondered how Google Images or Pinterest can instantly find visually similar images from billions of pictures? That's the magic of something called an image search system, or what we are calling as ISS for short. In today's video, I'm going to explain in plain language what an image search system is, how it works, and two popular ways to build one. And I should not say too popular because there are other methods as well, but these two methods will give you some sense of how the overall architecture looks like. So the first method that I'm talking about is called metadata approach, and the second method is called clip based image search system. Okay, so these two methods are what we are going to be talking about in this video. There is no coding involved in this video, just pure understanding. So if you are curious about the tech behind the image search, stay with me till the end. Okay, so let's start with the basics. Okay, let's start with the basics and imagine, let me open a note. Imagine that you have a database of 10,000 or let's say even 10 million images. Okay, so what we have here is a database of maybe 10k or 10 million images. Now you want to build a system where user can either type a query. So the idea is that there is going to be a query, user can type a query, and this query can be either a text based query or a image based query. So user can type a query and the system will return. And what is this system I'm talking about? This is some sort of, maybe right now we can call it a box, a black box image search system, that is ISS, and it will return the most visually similar images ranked from similar to least similar, most similar to least similar. Okay, so ranked results. Okay, so let me do one thing. Let me put this thing aside and let me do something else, and let me now talk about the core job of an ISS, that is in image based search system. The core job of a image based search system is this: take a query, understand the meaning of the query, search through the database, and which database I'm talking about. So earlier I pointed out that this is our database. Okay, so this database we are talking about here, and finally return the top matches. Now think of it as a Google search, but instead of matching words, it's matching the visual content of the images. So this is a very high level introduction of image search system. Now let's talk about the first approach, and the approach that we are talking about here is the metadata-based approach. Okay, so one of the simplest and oldest ways to build an image search system is through metadata. Okay, through metadata. Okay, so what are we talking about here? And here is how it works. Again, we are talking about the same database that we were considering earlier, which is it could be 10k images or 10 million images. So this is our database, and every image in our database, the idea is that every image in our database is annotated with something known as tag. Okay, so for example, I can have image 1. Maybe this is the image of maybe a cute cat. Let me draw something, I don't know. Okay, so this is a cute cat. Now this cat could have a list of tags such as maybe cat, maybe something like animal, or maybe something like sofa, because cat might be sitting on a sofa. Okay, so and so on and so forth. So every image, be it 10k or 10 million, is annotated with these tags. Now the second point to consider is these tags can be created manually, and there are other ways to do these by maybe something maybe some sort of cloud service, and that is the third point, AWS recognition. So AWS recognition is an online service which what it does is take an image and it will return all the tags or categories that are present in the image. So using this we can automate maybe if you have 10 million images, what it could do is this AWS recognition, it can automate this process. Now doing this manually is painful, right? But this is how the metadata approach works. Okay, but what is the underlying, like, so what I have just discussed is a big tagging process, but how exactly is the matching takes place? So once all the images are tagged, a text query, so maybe my query is cat on sofa. Okay, so this is my query. Now what will happen is this is matched against the tags. What tags? Because what we have is stored here is list of images and tag pairs, and what we do is we take this query, we split it into words, and we take individual words and we try to match it within the database that we just created in the previous step. Now the system retrieves all images whose tags match or are semantically similar. Now there are tools to make it easier and fast and scale it better, and one such tool is Elasticsearch. I won't go into how exactly Elasticsearch works, but this is how we can scale it. Using Elasticsearch we can scale it, and again this is how the meta approach works. Okay, let me put it aside for a second and talk about some of the maybe problems. So this is a very simplistic approach, and the problems are that tag might not capture complex or contextual relationship. Okay, no context or complex relationship. Okay, because tags are existing in their own, and one tag cannot talk to another tag. Okay, further, automatic tagging is expensive. So for example, if I think both approaches, one second, let me erase this and let me write, this is expensive. Okay, and the reason it is expensive is because if you employ humans to tag, this will be expensive, but if you use AWS recognition, it won't be that expensive, but still it is prone to error because we are automating this tagging process on 10 million images and there is no human review. So we should be very cautious and be wary of mistakes. Okay, so AWS can make mistakes, although it's quite sophisticated these days, but Again, so these are some of the problems with metadata based approach, and this is why the industry has shifted towards something known as deep learning based approach. And in particular, I'm going to talk about one model called clip, which is very powerful, I think, because I personally used it and it's just wonderful. Okay, so let's put it aside and let's talk about clip. So clip stands for Contrastive Language Image Pre-training. So notice these two words, LI. LI stands for language and image. So what it does is it takes text and it takes images and it does some sort of embedding production on pairs of text and image. Okay, so it stands for language, image, and P stands for pre-training. Now the idea, the genius of clip is that it learns a shared language. So although text is already a language, but it learns to map text with the correct images. So what it does is it converts both text and images into something known as vectors. Okay, and these vectors, so for example we can have a text vector. And what is a text vector? Text vector is the vector text representing the image. So for example, I have an image of a cat. Text could be a cat sitting on a sofa. So we can have a vector. Vector is just a list of numbers, and we can have actual image vector. Again, this is also a list of numbers. And the intelligent thing about, the genius thing about clip is that these two vectors will be so let me, although these vectors are in very high dimension, but if we have to plot these vectors, these would be very close in the in this two-dimensional space. If let's say we do some sort of PCA or PSD kind of thing, which reduces these dimensions and helps us visualize vectors in high dimension. But don't worry about it. So the idea is that both numerical representation points to the same thing. That's the genius of clip. This means if you write cat on a sofa, the text gets converted into a vector, and that vector will be very close to the image. So every image is also going to be converted into vector, and when you search, the system just compares these vectors and finds the images that are closest to the text vector. Now you can think of it like a map where text and images that mean the same thing are located close together. Okay, so just one more time, what I can do is 1 second, let me put this aside. Okay, and what I can do is I can consider this whole space as a map where, let's say, this is an image and this is a text. Okay, all the images which are similar will be packed together, and also text which points to the same thing which is in the image will be packed together in this map. Okay, this approach doesn't rely on predefined tags. Instead, it understands the semantic meaning of both images and text. Companies like Pinterest, Unsplash, or even Instagram's Explore tab use variations of this idea. It's faster, smarter, and requires less manual work. Although there are more technical aspects such as something known as vector database. We can talk about that in some later videos, but I think that's it for this video. I just wanted to discuss these things. Now, just to wrap up, 1 second, just to wrap up the things, what I'll do is I'll probably put it also aside. Okay, just to wrap up things, to recap, now what is a image search system? So ISS is a system that takes a query and returns a list of images. The metadata approach uses tags. Metadata approach uses tags for matching. It's simple but limited. And clip uses deep learning to learn the relationship between images and text. In future videos, I can show you how to build a mini image search system using clip and a tool called FAISS. Now this is an open source tool for doing something known as vector search, which can handle millions of images. So let me know in the comments if that interests you. If you found this video helpful, give it a thumbs up, subscribe to datageekrj for more AI and ML content, and drop your questions in the comment below. Thanks for watching, and